All right, so a number of us went back this year, and it was just as massive as it's ever been. The logistics are a little bit better than they have been in the past, but I heard various reports from 65,000 attendees to maybe 85,000. It certainly felt like a lot. When you go to reInvent, there are over 3,000 sessions. They're now sprawled across multiple hotels. There's a lot to take in. I had a placeholder here, 300 plus announcements. Feels right. Didn't actually get a number from them, but they announced a lot of things, big and small, from major new services to augmentations to existing services, all kinds of things. This year, some major themes were around machine learning, serverless, and more of an enterprise focus on enterprise transformations. Sometimes people kind of ask me, you know, with everything that's going on in AWS, and but there are a few ways right here. Here's the official AWS news blog, where you get the announcements direct from AWS. There's also Jeff Barr's blog. He's sort of their tech evangelist, has been for years. There's also some good podcasts. This is the logo of the AWS Morning Brief, put on by a very goofy guy named Corey Quinn. And he does the Morning Brief, which is kind of a recap of all the deluge of announcements you get from AWS, help kind of parse the changes that are coming down the pipe. And then there's Screaming in the Cloud, which is more of an interview-based kind of format where it's not just AWS, you'll get into Google Cloud and Azure and other cloud sort of oriented topics. Then there's also the official AWS podcast. So another way you can keep up is by doing just what you're doing, coming here and listening to sessions here at DeepComposer. You can see the schedule here. We've got more things coming next week, Tuesday, Wednesday, and Thursday. Come back for more topics, more food. We've got Dan and Amy presenting on Tuesday on DevOps and security topics. AI and machine learning from Tony on Wednesday, along with an interesting one from John Pazavilko about AWS Outpost, which is AWS' way of sort of taking some of the cloud and letting you have it on premises. And finally, we have James Smith and Tom Marinette on Thursday. James is going to talk about how we manage our sort of massive footprint of AWS and all the organizations that go along with that. So there's some interesting topics there. And then Tom is talking about media and streaming video content. Pay attention to that one. All right, a few quick hits. I'm going to run through some stuff. What happened? One interesting announcement is S3 access points. This is kind of a minor thing that's going to help us to better control how we give people access to S3. I can give Pete a different access than I can give Ben to the same bucket. Gives us a little bit more flexibility. Another quick hit. This is a picture of an outpost. What does it actually look like when you bring AWS hardware on premises? Kind of looks like a server rack. It's going to be very interesting to see what all you can do there. You obviously have to provision some stuff in advance. I understand they can do auto scaling, but it involves nano machines. John Foss will talk more about that. This is just a screenshot of something called SageMaker Studio. Machine learning was a big theme. SageMaker is Amazon's platform for doing machine learning in the cloud. And they've created a whole developer experience built around this IDE called SageMaker Studio. That is bound to come up in Tony's talk. This is an interesting one. A couple weeks back, I remember hearing about something called quantum supremacy. I can't think of which company did this, but it was some achievement in quantum computing, and I thought, wow, this is amazing. I wonder how long, I'm thinking to myself, just sort of jokingly, how long until I could just sort of order one of these up in the cloud? A week I waited. And I don't know what this is. This may be just a big goof from Amazon, but they've got something where you can spin up some quantum computing, but God only knows how much it costs or what you can do with it. But it is just kind of amazing to consider that this incredibly advanced technology is available to basically anyone in this room if you know what to do with it. All right, so I'm going to take a slightly deeper dive into some other topics here. I want to talk about something a little bit closer to home, Fargate Spot. I'm going to explain a little bit about what this is, but I'm an applications guy at heart. I've been a developer in my past life and more in the DevOps and deploying of applications. And one of the things that we think a lot about is how do we get applications out to our users and how do we make sure that they're robust, and stay up, and they're easy to deploy, and things like that. So let me explain a little bit about what this is. I have to go through a few things. I I don't know if you're familiar with the different purchasing options that you have in AWS, but there's the idea that the cloud is scalable and flexible, and so you sort of pay as you go. You're not buying servers, you're renting servers. So the most basic way to do that is to pay the on-demand price. You kind of just walk up, no questions asked. There's a certain price on a certain size of a virtual machine, with its CPU and its RAM and however much, graphics capability it has. They cost different things. There's one rate. You pay by the hour. So the price is the highest. It's the highest you can do because it's the most flexibility you can have. You just walk up and you buy it. There's another thing called reserved instances, which requires you to forecast out a little bit. You need to know, okay, I'm going to use this certain type of instance or this certain family of instance. I'm pretty sure that I'm going to use this, this whole year, or at least I'm going to have enough for work that I could say to Amazon, I'm going to buy this type of instance for a whole year or even 3 years, and they will give you cheaper prices if you pay it up front or pay that kind of installments. But it requires you to know what you're getting into. There's a new thing that I am ill-equipped to explain called cost savings plans. And it basically takes the idea of reserved instances and it makes it something that's hourly and it's a lot more flexible, and it looks like it requires a PhD, but I think it actually doesn't. We've got people that are pretty well versed in stuff.
We bought one last week.
See, James knows about it, so you can ask him next week. But really, it's the idea that if you can plan ahead a little bit more, you'll get the cost savings out of it. There's something else called the spot market. This is where you can get very deep discounts, 60, 70%, sometimes higher, at the cost of a little added complexity. So what even is this? Let's set the table. All right, if you're Amazon, you've got physical servers somewhere. We don't have to worry about physical servers, but of course they do. So you've got data centers just filled with racks of servers. And their business is selling them to us. Every time we spin up a VM, we take a little slice of one of those machines, we pay for it. But at any given time, they've got some that are just sitting there idle. They don't really turn off the machines because they're chopping them up into VMs. So they've got, when we say they've got space, what it maybe really means is 30% of this CPU is free, or 30% of this machine, or maybe they have blades on the rack that aren't in use. That's unused capacity. It's something they could sell and they're not selling it. So that's where the spot market comes in. We've got this unused capacity. We're paying for it anyway. How do we sell it to people? Well, we put a really big discount on it. And we as the buyer think it's slightly more complicated because we have to look at what the price is. The price of an instance on the spot market, that unused capacity, fluctuates. It can be very low. It can raise and lower with demand. So you can go into the EC2 console and you can see what the price history on the spot market for a certain instance type is. Because when you want to buy one, you don't just say, I'm going to buy one. You say, I'm going to bid. There's a certain price. In this graph, the on-demand price for the M4 large here has been, the on-demand price is 10 cents an hour. And you can see the fluctuation of the spot market by different zones. This one's, it's down to like 4 cents. Really a big discount. If you're running a bunch of these, you're running it for a long time. So maybe you put your bid sort of right there underneath. We're going to bid somewhere in between here, 7 cents. You get your instance for 7 cents an hour. That's 30% savings right at the top. And sometimes the gap is quite wide and you go very low. There's some caveats to this. That unused capacity, they might want it back. If the on-demand market has more demand, if people start paying that sort of on-demand price and they need that capacity back, they're going to yank the machine from you. Or if the price changes in such a way that your bid is now higher than what it would be on the on-demand market, your instance goes away. Poof, the instance is gone. And so you take a risk. You're getting a deep discount, but your instance may potentially go away. But don't worry, you get a warning. You get 2 minutes warning. So what use is this? Why would I ever want to use a server like this to give services to people that depend on me, applications I'm providing to campus, when the server could just go away at any time? Well, there are actually some really good use cases for this. If you're in, doing more research computing, there are parallel tasks that are really good for this, and actually highly available web applications. How can that be? Highly available servers that could go poof doesn't make sense. Well, there are things that you can do. Let's take a slight diversion and talk about containers. So when we deploy applications, a lot of times what we'll do is we just have a server, and we have our code that is the application, and we'll put it on the server. Containers say there's going to be a little bit of extra wrapper around that application. We're going to sort of create a small VM. And if you know containers, you know I'm sort of simplifying some things, but basically we isolate the app in something called a container and put it on the server. And then we can put it in multiple copies. You know, we can do the same thing without containers. We can load balance an application, put copy over here, copy over there, two different servers, load balance them together. That way we get double the capacity. If one goes down, the other one's still here. With containers, it's a similar concept. Each of these containers, or what's called a task, is distributed over multiple computers. So how we might deliver, oops. Oh yeah, I just wanted to point out here, the, the logo for Amazon ECS, Elastic Container Service. Now they've got this sort of sensible in line with their design identity thing, but it used to look a lot like, what does that look like? Does anybody? Yes. The space station from Deep Space Nine. I don't know why they got rid of it. So you take an application, you point your load balancer, you point to what's called a service, which is the distribution of tasks. So one application might be a task that's on multiple machines. And in between here is something called the control plane. If you've heard of Kubernetes, that's one. ECS, the Elastic Container Service, is an alternative to Kubernetes before Amazon had Kubernetes capabilities. But all these things have to get distributed across actual virtual machines. And that control plane kind of helps you, put these tasks in places so they can be highly available. So what if we were to just say, hey, these are all spot instances now. Hey, we just saved a ton of money and everything's distributed and we're happy. But of course, they could go poof. So that doesn't work. And I want to point out also, you've got the management of this fleet. That's something that you've got to constantly be taking care of. Maybe it's an auto-scaling group or something like that. So you put this in an auto-scaling group. And there's a new feature that actually came out last year called mixed instance strategy. You create an auto-scaling group and you can say, okay, 2/3 of this I'm going to put on the spot. 1/3, I'm going to pay the on-demand price. I know it will never go away. I take priority over everybody. So in this case, 2/3 of your fleet could go away, but you still have guaranteed capacity. Your capacity might be diminished, but you're always going to be serving up a web application. And you get the price advantage of being on spot. So that's really nice. Also, anecdotally, people say, hey, spot instances don't actually disappear nearly as often as you might think. I've heard people say, I've got some that have been running for months, years even. So there's not necessarily that much volatility, and you can diminish the risk quite a bit by doing something like this. But you notice one thing, look at our report task 3 over here, it has ended up where it's only on a spot instance. So that application is at risk. In fact, you could replicate it because that's what you're supposed to do with containerized applications, but the control plane, ECS doesn't really understand what's going on down here. It's just putting things on servers. And so you could end up in a situation like this, where even if you're trying to scale out task 3, which is a web app in this case, it's still just only on spot instances. So it's at risk. That's where something called capacity providers comes in. This is where AWS lets us basically clue in the control plane to what's going on and say, all right, there's different types of instances here in this fleet. Make sure that you don't ever just put these all on spot. Put them some here and some there. And so we get that security of having the mixed fleet type for everybody. But I started this with Fargate. So you're probably wondering, when are we getting back to that? I did say this is your problem, managing that fleet of servers. Fargate takes that fleet of servers and replaces it with magic. It's a managed service now. And when we say managed service in AWS, the main thing you need to know is that something that was your responsibility is not anymore. It's Amazon's problem now. And really, that's the case. When you're on Fargate, you don't spin up servers. You just handle this stuff up here. You know about your containers, and you tell the ECS service, I've got these services, deploy them somewhere, and you don't see servers. It does it, and there are servers under the covers, but you never see it. It's magic. So what about Spot? Fargate Spot just announced. Basically, you can tell Fargate, take care of all my servers, and make them Spot, and just do it for me. And as near as I can tell, I don't know this for sure, because I haven't been able to confirm it, I don't think you even have to do the bidding. I think you just say, hey, AWS, manage my servers and save me a lot of money, please. And he just does it. And you still have the things you have to worry about the mixed instance types, but you can do that because there are capacity providers in Fargate. And you can say, hey, Fargate, manage all those servers and make this percentage of them on demand and this percentage of them Fargate Spot. It just does it. It's very cool. So,
is your, sorry to interrupt.
Yes.
Is your danger of losing Spot instances in that case, Fargate, does that get mitigated or minimized at all?
Well, it's still subject to all the same risks that are inherent to Spot. The thing that I'm less clear on and I need to find out more about is how it doesn't seem like you set a price. So how that price is set, of course, has an impact on when they get taken back. So it's something we would have to look into more. But the point, generally speaking, is that there is a lot of opportunity with Spot for cost savings that we're not currently taking advantage of. And a lot of the risks that seem very risky when you read about Spot, there are great ways to mitigate them. I mean, as long as you can distribute your task, and it's not just for containers even, as long as you can distribute across multiple instances, you can take a strategy like this and have part of your fleet be Spot and just save a lot of money, especially if you're highly available already, so you have multiple instances. That's the thing to do. So ECS plus Fargate plus Spot, there you go. All right. Just a brief note on that. The pricing is a little bit different between EC2 Spot and Fargate Spot. Slightly different concepts. So the savings are even greater if you're just on EC2, 90% versus 70%. DeepComposer. As I said, machine learning was a big theme of this conference. They really want to democratize machine learning. This is a slide I saw. They want to put it in the hands of every developer. It's not something that I personally know a whole lot about, but I'm very interested in it. And I just came out with something called DeepComposer, which is what I would call sort of a toy, a machine learning toy that joins a couple of other devices that have come out in recent years. There's the camera there called Deep Lens. There's the thing called Deep Racer, which is the car next to it. That's got a machine learning powered camera inside it, and they show you how to program it so you can make it drive itself around a track. They have competitions, and it's something that would be really fun to play around with. The last thing is this thing called DeepComposer. DeepComposer itself, as we'll see in a minute, is not going to exactly blow you away. I see it as really a vehicle for teaching a concept in machine learning that they introduced, to me at any rate, called generative adversarial networks. We're going to dive into Brandon's extremely superficial understanding of machine learning right now. The idea in what's called a GAN is that you are trying to create something new. That's the idea of DeepComposer, is that you play a little bit of music, a melody line or something. It's going to try to augment it. In fact, let me skip ahead a little bit and show you this.
DeepComposer keyboard here. And what I'm going to try and do is play a simple melody. We'll send that melody up to the cloud and we'll generate a complete song. All right, no pressure. Here we go.
The keyboard here, I will say, unlike the other two devices, nothing at all special about this. There's no extra CPU chip in here or anything. It is just a MIDI keyboard. They sourced them from somewhere, slapped an AWS logo on them. You don't even have to use a keyboard for this. You can play on your actual computer. So what it's going to do...
Let's go ahead and send that to our rock generative model. In about less than a second, we'll go ahead and we'll generate all of the accompaniment. So here we have guitar, bass, synth, drums. Let's go ahead and have a listen.
I'm going to stop there because we have a ton of time left. But basically what this thing is doing is trying to generate musical accompaniment to the song. I've seen things like this. I have a phone on my iPod or my iPhone that will take, if I'm strumming along and try to put bass and drums underneath. I think this works quite different because this is based on machine learning. The idea in this adversarial network is you have two adversaries. You have a generator trying to generate music, and you have something called a discriminator, both different algorithms. This one is trying to create music. This one is trained to recognize if a bit of music is created by a human or not. Okay? This kind of distinguishing between kinds of things was something I saw a lot. I saw a presentation from one who said, I didn't know anything about machine learning, but I learned how to do what's called like a classification algorithm. This is sort of your entry-level hello world of machine learning, from what I understand. You take a data set. In this case, she had a bunch of pictures of shoes from some shoe retailer. They were already classified into things like sandals and heels and things like that. You feed all that into the machine learning algorithm, and you iterate over time. And between each one of these iterations, you kind of tell it how well did it do at taking the knowledge it gained from this pre-existing data set and applying it to a new picture. And it take what it knows, look at a picture of a completely different shoe, and decide, is that a boot, is that a heel, whatever. And in between each of those iterations, you give a little nudge. You were right in this area, not. And that's the sort of data science and machine learning that, where is that coming from? Anyway, so this kind of classification. So you've got the generator trying to create music, and you've got the discriminator telling it whether it's human-made or not. And the idea is that you pit these two things against each other until they converge, and the discriminator can't tell the difference. And so that's how it's generating that song there. I'm compelled to point out that based on this picture, I thought that looked a little familiar, that one too. This is precisely how Ultron was created. Did you remember this? Yeah, I don't know. It may come up in a second. Blue blob of computer stuff, orange blob of computer stuff. Yeah, see, it's very bad. Anyway, I don't have enough time for jokes right now, but it did look very familiar. DeepComposer is very interesting. Unfortunately, I can't really demo it for you because it was in preview and they haven't released it yet. And one thing I found really fascinating with this is it doesn't actually do anything with the audio. It doesn't know anything about music theory or notes or timing or anything. It looks at stuff like this. This is a piano roll. This is what you get if you're playing with a MIDI instrument, any sort of musical generating bit of software. You can play in a real keyboard, and it will sort of paint the picture of what you play. And if you don't know how to play piano and you're creating this kind of music, you can use your mouse and you can, get piano into your composition that way. It's just a thing that musicians have been doing for a long time. DeepComposer takes a picture like this and applies computer vision principles to it. It doesn't know about music, but it knows how these pictures ought to look. And it knows the kind of pictures that it can try to create that will match up to the one you do by playing Twinkle, Twinkle, or whatever you do. So in this demo, they open up a SageMaker application for us. And what you get is a Jupyter notebook. It's Python code. And you can see step-by-step how it went through. It took a sample of Bach. And it's trying to be able to augment any piano you play in the style of Bach, whatever. That's kind of ridiculous. But the idea is, it gets closer over time. And you can see that it pretty big. You can see, first iteration, there's a tune, and it helpfully kind of goes, bah, bah, bah. It's nonsense. But over time, it gets a little closer. By the time it's 1,500, 2,000, you actually see, amazingly, no idea how, it has managed to land on something that sounds like chords. There's some harmonic, cohesion to it. Really interesting stuff. You can find lots of fun, snarky takes on DeepComposer online because it generally produces kind of bad sounding stuff. I managed to come up, they were sort of incentivizing us to publish something on SoundCloud because it's baked into their console. And now what you can't tell there, is that was Somewhere Over the Rainbow. And I actually pulled the piano part out and just left the other instruments. And so something new sounding, but it sounds like music. It doesn't sound like random noise. and that's, we're nowhere near saying, all right, we don't need people to be creative anymore. We have computers. We don't. That's not the point. The point of this to me is that it showcased this really interesting advance in machine learning, and sort of taught me a little bit about this technique that I didn't know about before. So I thought that was cool. One more quick hit about machine learning. They had this builder fair, which I thought was really cool. And the only thing I want to say about it is I met a couple of people who worked on this program right here they call Puente. And they took that kind of classification algorithm, just like with the shoes, and they applied it to American Sign Language letters. And they came up with something that you could stand in front of a webcam, just any regular camera, and they said, make the, spell a word. Here's how you do it. Make the word. And it would recognize the patterns that you're making with your fingers, which has all kinds of interesting applications. So the only thing I really want to say about that, besides all this stuff is on GitHub, I actually was thinking about trying to build that for demonstration, but ran out of time. But if you're interested in machine learning, I am too, and I'm thinking about maybe trying to get something going. So if you are interested, come talk to me after. Maybe it's something that we can get some folks together to kind of dive into and do some stuff over lunch sometime.